Okay, so we are on question 3, and this one we want to look at broadband use and whether or not the participants have children. But notice that each of these data sets have, they're not numeric. So we have to fix that. We can't run any sort of test on these because they're using words instead of numbers. So let's fix that. First thing we want to do is move the information to a new place. Okay, so we'll just scoot it over here and we're going to code this with zeros and ones. 1 would mean it's a yes and 0 would mean it's a no. So to do that, let's do an if statement. So equals if parentheses, and you can click on the cell, so F2 equals quotation marks, yes, and then comma 1, comma 0 in parentheses. So that's saying if this cell, F2, is a yes, coded as 1. If not, coded as 0. Okay, we're going to do the same thing with has children, equals an if statement, parentheses, H2 equals quotation marks, yes, in quotation marks, comma 1, comma 0. So same thing. If this cell says yes, we want it to be a 1. If it's a 0, if it's a no, we want it to be a 0. Okay, so far so good. Both of those say yes, and both of these say 1. And we want to drag this down to the bottom of our data set. And you should have noticed I clicked on the little plus sign. Right in the corner, you'll get that heavier box and you can click on it. It makes a plus sign and you can drag it down. And that will carry that formula down as far as you want it to go. Okay. So to test this, put your filter in and let's just take a look at this one. Put a yes. Now all of these should be ones. Looks good. You can even put the down arrow and it is. Everything's a 1. If I put a 0 or put a no there, well, now everything's a 0. So looks like it's working for that one. Let's clear that filter. Check it with broadband. Let's do a yes. Everything looks like a 1. Yep, so it's working. Okay, now you can do your descriptive statistics and see what happens. So let's go to data analysis, descriptive statistics. This time we're going to put both columns in. So remember, we're going to do both of these columns, K and L, and hit OK. Now, as you might suspect, when you have just a 0 and a 1, whether it's yes and no or male and female, it just doesn't come out very intuitive. So our range is 1 because our minimum is 0 and our maximum is 1, which means our median and our mode is 1. So the only thing that's of real value here is the average, which is sort of okay. And then the count, which we already know the count is 410. So for me, the descriptive statistics is not super helpful. Now we can look at confidence level. So again, if you want to do the confidence level of, let's do the broadband access, we need these two numbers. So we're going to do the lower and the upper. And we want to look at mean minus this. And we want to look at mean plus this. So this is saying with 95% accuracy, those that have broadband access are somewhere between 0.58 and 0.67. So again, not super helpful because it's looking like, well, that's somewhere between, around a half. And when we have yes and no's, well, everything's around that half marker. So not super helpful. I think what we want to do here is more of a correlation. Let's just see if these two variables are even related. So go to data analysis, and correlation. Correlation means we're going to look at these two variables to see, are they related to each other? Meaning, if people have children, does that mean they might also have broadband access, or vice versa? If you have broadband access, would you also have children? So let's do this with the correlation. We have our data set. It's both columns, labels in first row, new worksheet, and hit OK. All right, so it's not a big table, but it does tell us quite a bit. A one-to-one correlation means it's pretty much the exact relationship. So broadband access to broadband access better be an exact relationship. So 1 is a perfect score. Here we see less than perfect score, but how do we know if this is a good relationship or not? 0.03. Now, I already put this together with Cohen in 1988 put together this scale for us. So it's a small correlation if it's a 0.1 to 0.3. Well, ours is 0.03. So it's not even a 0.3, it's 0.03. So that would be somewhere up here, meaning there's no correlation. Does that make sense? So because it's a 1, it's a perfect correlation. It's large or perfect correlation because it's an exact match. But a 0.03 is not even on the scale. So these two aren't related to each other. If we wanted to look at some other variables, you could play with that and see if you get a better score. But these two by themselves are not related. Now, if we just want to see if one could predict the other, this is the first step. So if your correlation isn't significant, then you can stop here. But I want to go ahead and show you if we decided to do a predictive analysis, meaning a regression test. So go to data analysis. We'll look at regression. This time you have to put them in separate boxes. So broadband range, we're going to put in the Y. And children, we will put in the X. All right, we have labels. Make sure you click on that because we included the title of the column. You can put confidence level if you want. And then we'll put it in a new worksheet. That's really all we need to do right here. So let's hit OK. All right. Now, there's a lot of information here, but the first thing you want to zero in on is this p-value. The p-value tells you if it's significant or not, and the p-value should be less than 0.05. So we're looking at less than 0.05. Some people even go as far as less than 0.01. In this case, our p-value is larger than 0.05. It's a lot larger. It's 0.5. So that tells us there's no significance with these two variables being run together. If this was less than 0.05, you could say that there is a relationship between having children and broadband access. In fact, one would predict the other. So I reran this. I'll go ahead and show you here. I reran it with the variables in different boxes between your X and Y axis. And I just wanted to show you that that p-value, 0.506, stays the same. So whether we have broadband in your X or Y axis, or we have children in the X or Y axis, the p-value stays the same because we're basically just looking at how do these two variables play together. Is there a relationship, which we found in correlation that there was not a relationship because this is too little. And then the p-value here is too big. So these two variables not related, and one cannot predict the other. So that's with your question 3.